Hello students, welcome to the University of Galway. Welcome to engineering. You've chosen very well, especially if you chose mechanical engineering. My name is Nathan Quinlan. I'm going to tell you a little bit of the story of the Galway energy efficient car and a little bit about what it has taught me about engineering and what it is to be an engineer. The Geec has been built, designed, raced by many students over the last 10 years. It competes in a race where the winner is not the fastest car, but the car that uses the smallest amount of energy to complete the course. 4 lecturers are involved in the Geec: Dr. Rory Monaghan in Mechanical Engineering and Energy Systems, Professor Martin Glavin, Electronic and Computer Engineering, Dr. Maeve Duffy on the Electrical and Electronic Engineering, and myself on the mechanical side. And this is what the Geec looks like when it's racing. It has achieved a performance of 354 kilometers for every kilowatt hour of electrical energy that it draws from its battery. That is not just a bit better than ordinary cars. That's equivalent to about 10,000 miles per gallon of diesel, which is about 200 times better than most cars on the road with internal combustion engines. And it's about 100 times better even than cars that are on the road with fully electric propulsion systems. And that performance ranks 13th in Europe. So the first thing I want to say about engineering that I've learned from the Geec is that engineering is really a way of thinking and a kind of a set of tools. And that's what we try to give you in your 5 or 4 years with us here. We're not going to teach you how to design a car. We're not going to give you a recipe, a set of steps that you will remember. We'll give you a set of mental tools and techniques and practical tools and techniques to help you to figure out the things that you need to do and to learn the things that you need to do to really be an engineer. Sure, we'll teach you to design some things, but we're not going to teach you to design everything. If you were an art student, nobody would be teaching you to repeat every brushstroke that Picasso did in some painting. They teach you the insight and the understanding and the techniques. For example, in the Geec, we didn't teach anybody to design a car. We lecturers didn't know much about designing cars until we started helping students to do it for the Geec. And there are many problems you have to solve when you're designing a car, many things you have to achieve in the design. One kind of basic one is that the car should not fall over. Okay, these ultra efficient cars, they tend to be high and narrow for aerodynamic reasons, and because of that, they're prone to falling over. And I want to emphasize that the cars in this video are not the Geec, and nobody was hurt in these incidents. We've got to design so that that doesn't happen. How do we do that? We use our tools, our techniques. One of our really important techniques is the whole world of Newtonian mechanics. This diagram here is one of the first pieces of work that any student did in designing the Geec, and it's a diagram of the forces that act on the car as it's going around a corner and braking, and it's an investigation of what it takes for those forces to make the car roll over. There's a bit of science, there's a bit of maths, and that student was able to generate a set of charts that tell the team where it's safe to put the center of gravity of the car in relation to the width and length of the car so that it doesn't roll over. That piece of design analysis was really very successful. Here is the Geec going around a corner, actually one of the corners we saw in the last video, and you can see it's cruising around the corner easily, even overtaking other cars on the corner. And in fact, it turns out the Geec doesn't even have to slow down to go around corners. That's a good thing, not because we want to go fast, we don't, but because the kind of motor that's in the Geec has a very narrow band of speed where it performs well. And we want to try to keep moving at that speed. If we have to slow down for a corner, then we're not using the motor at its ideal speed and we're being inefficient. Even worse, if the driver has to use the brakes, then it's game over for energy efficiency. So you can see here the Geec can really just again cruise through the tightest of corners, and that design analysis was something that had far-reaching implications for the design and the performance of the car. And it came from very well-known engineering ideas, very general ideas that can be applied to almost anything. And the trick here is just to think about what happens when a car falls over or doesn't fall over, and to recognize the connection between that and textbook Newtonian mechanics. So there are lots of tools in the engineering mental toolbox, science, mathematics, practical testing techniques, and it's those techniques and that kind of way of thinking is what we try to give you during your time as a student. Second thing that has really crystallized for me in working with the Geec is that engineering is a creative activity. Some people think that engineering and art are at some kind of opposite ends of some kind of a scale. Some engineers think that art or creativity isn't serious because, I don't know, it doesn't have right and wrong answers, or it's easy or something. I think both of those points of view are wrong. I think engineering is just it's another kind of a creative activity, using all our engineering tools and often with a clear purpose in sight, but it is intensely creative. It is not, we don't design things by, again, we don't follow a recipe. We don't design things by grinding out some set of predefined steps. For example, I'm going to show you here some images that kind of a sort of a time lapse of the creation and the design and the building of the second generation Geec body shape. It's primarily an aerodynamic design process. There's lots of aerodynamic analysis and simulation applied here in order to search out the right shape. There is a lot of work to translate, to do the detailed design on that shape and to fit the rest of the car into it, and then to actually build it, to turn it into a physical reality. And it's, this is creative. And what comes out at the end of it is a shape that, in my opinion, is very elegant and classy to look at, but it has layers of beauty in it, inside it, that you can appreciate if you understand why this is such a good aerodynamic shape, because of all the thought and the care that went into that design and went into physically realizing that design. And the third thing is kind of related, and again, there's a stereotype that engineering is cold and it's sort of robotic. It's absolutely not. Engineering is fun, and that's something we don't talk about enough. It is a very human activity. It's full of emotion, highs and lows, and we certainly experience that in the Geec, working with other humans, doing all the human stuff and having all the human feelings is very much a part of engineering. And I can tell you there is nothing quite like the feeling when you see a thing built, doing what you intended it to do, something that started as an idea in a few minds and progressed onto a sketch on paper and progressed into computer models and finally became a reality and did what it was designed to do. It is absolutely a joyous thing to be a part of. Human emotions are human emotions. There are lows as well as highs. Things go wrong, and that can be that's hard to get through. But we engineers do push through it, and like I said, when it does what it was meant to do, it's very special. Here's the Geec getting a score. And here's a little video, another video of engineers having emotions and having feelings, and even talking about their feelings.
Do you have feelings about building stuff up just to get it crashed?
Trying to make me cry right now. You know what? I was really ecstatic. I watched it for the whole hour that it flew crosswind. And that was amazing.
Like, who can say they were a part of achieving something so beautiful, and heart-wrenching at the same time.
Working on something hard for a long time as part of a team and watching it work exactly as you had intended it to is as good as it gets.
So that documentary, Pulling Power from the Sky, I highly recommend it. It's on YouTube. It's the best thing I've seen about engineering. It's about some really amazing technology as well, but it's really about the experience of being an engineer and doing it. This is the Geec team winning the Technical Innovation Award for the best piece of technical design work at Shell Eco Marathon Europe in 2018. Best in Europe, engineering students from the University of Galway. So remember to enjoy your time as an engineer, as an engineering student. We hope that you have a good time. It's not always going to be easy. It's not always going to be fun. Okay, we are going to challenge you. We're not always going to give you easy answers, because what we are doing is trying to prepare you to go out into the engineering world and figure stuff out for yourself and create amazing things. So good luck, and remember that everybody here, everybody who works in this university wants you to succeed and be the best engineer you can be. That's our job. We're here to help you. And I look forward to seeing you over the next few years.